Hey everybody, I hope you're doing well. In this particular video, I want to talk about how the first and second derivatives can show us the shape of the graph, increasing, decreasing, concave up, concave down, and I'm going to use number lines to organize all my thoughts. So here's the idea. I have a function. It's a quintic function. So as soon as I have a higher order polynomial, I really don't want to do this by hand, so I'm going to use Mathematica to do most of our work. So I want to determine the intervals where I have increasing, decreasing, concave, and concave down. So here's the process. I got a whole bunch of steps here. The first thing I want to do is find the critical values. I'm going to choose test values, and I'm going to transfer this to a piece of paper to keep track of things. And I'm going to do the same process for the second derivative, the second order critical values. So in order to do this, I first need to enter in the function into Mathematica. And I did this already. I'm going to hit a shift enter, and that's going to enter this into Mathematica. Now, how do I find the critical values? Well, that's where I can use the solve command. And I am going to set the first derivative equal to 0. And since we have a polynomial, I don't have to worry about derivatives being undefined. In other words, non-existent. So there's the command. That's the line that I need to figure out my critical values for f. Another shift enter. And you see I wind up getting 4 outputs. Only 3 numbers, but 4 outputs. So I want you to imagine these numbers, -2, 3, and 4. Test values. Test values are the numbers that are between these numbers here. So I can pick 0, 3.5, and 5. But don't forget things that are less than -2 as well. So I want to do some test values, and these test values, I'm going to pick something less than -2. Let me say -3. Pick a number between -2 and 3, I'll pick 0. What about between 3 and 4? I'll pick 3.5. And then something bigger than 4, I'm just going to choose 5. So I have 4 inputs there, so I should have 4 outputs. Another shift enter gets me these numbers. Now I want to transfer all of this to my sheet of paper. So this is how I'm going to do it. I'm just going to transfer it. I have my function. It's the derivative that I'm transferring over here. And I'm going to put my critical numbers down on here. They are -2, 3, and 4. And this is highly not to scale here. My test value, when I plugged in a number less than 2, I got a positive answer. So I'm going to put a plus sign up there. A number between -2 and 3, I got a negative answer. Between 3 and 4, I also got a negative answer. Greater than 4, I got a positive answer. Now, step number 2 was to transfer my information onto the piece of paper, and I want to label it. Well, this is partially labeled right now. It's not fully labeled. This f is increasing. The minus sign, f, is decreasing. This only takes a few seconds for each interval. So please write that all down. Now I'm going to go through the same process for the second derivative. So let's see how this goes. The second derivative. I'm going to solve not for the first derivative, but the second derivative being 0. and I'll do a shift enter, and this time I wind up getting radical answers. I'm going to convert all this to decimal very quickly by putting capital N in front and do another shift enter, and now I get decimal answers. Again, I'm going to go through and I'm going to choose numbers in between those three given numbers. Well, in fact, I still need to pick 4 numbers. But this time, I'm going to plug them into the second derivative. So a number less than negative 0.68, I'm going to choose negative 1. A number in between, and then the hardest one here, well, I think I can pick 3.5 again. And then a number bigger than 3.68, I'm going to pick 4. So each one of these numbers sits in a different subinterval. I will evaluate this with another shift enter, and what I'm looking here is for the sign of the number. So let me transfer all of this to my sheet of paper. Now this is where I have to be a little bit careful. What I want to do when I put my second order critical numbers on here, I want to make sure they line up with the ones that I already have. So I have negative 0.68. I'm just going to round to 2 decimal places for this. That's around here, negative 0.68. Then I have a 3. Well, that's right over here. Just make sure these are lined up. And then I have a 3.68. Well, that's like right about here, 3.68. This is my f double prime, or my second derivative law. Now, the test value that I chose over here was negative 1, and that produced a negative answer. Then I wound up getting a positive, a negative, and then the last one is a 90, and which is positive. Now my labeling. I want to transfer this, and I want to label this. So this says F is concave down. This plus sign, F is concave up. And then the same thing for these. Concave down, F is concave up. Just take a few seconds to write this. And now we're down to the last step. I'm supposed to combine this into one number line. And this is how we're going to do it. Draw my number line. And every time that I have a number, I'm going to transfer it down here. Negative 2, negative 0.68, 3, 3.68, and 4. This interval, I know F is increasing and concave down. F is increasing and concave down. In this interval, I know F is decreasing and concave down. This one, F is decreasing, but concave up. Here, they're decreasing and concave down. So I'm just kind of looking up vertically on this picture. I hit this place and this place. I have a decreasing, I have a concave up. So this one, F is decreasing, but concave up. This last one, F is increasing, and it's also concave up. So these are all my intervals and my shapes for this particular polynomial. Now if I plot this, let me go into Mathematica at the very end, and I want to plot this and see if what I drew or what I wrote down on my combined line actually makes sense. So I'm going to plot this. The function is f, and I know x is going to range from my something smaller than negative 2 to something bigger than 4. I'm going to choose -5 to 5. I think that encompasses all of those values in question. So let me plot this. And I wind up getting this. I have a increasing concave down. It goes from this maximum, goes decreasing concave down, to decreasing concave up. And this little area right here, where there's a 3 in between here, this is hard to see all of this stuff right here because these numbers are very close to each other. 3, 3.68, and 4, they're hard to see. So what I'm going to do is I'm going to copy this. I'll paste it down here, and I'm going to go from 3 to 4. And let's see what's happening between 3 and 4. So it's supposed to be decreasing in concave down, and then decreasing in concave up. And that's exactly decreasing concave down, decreasing concave up, and that inflection point is at approximately 3.68. So I hope you found this video helpful. If you have any questions, let me know. Have a great day. Bye.